same thing, distributive property. Square root of 3 times 2 is 2 square root of 3. Usually put the normal number in front, the whole number. What's square root of 3 times square root of 3?
That's just...
Yeah. Square root of 9, which is normal 3. Anytime you take a square root times itself, it just becomes the normal number. And those don't mix. Five minus square root of 2. What kind of problem is this?
Foil.
Foil. You guys remember what FOIL stands for? First, outside, inside, last. So if there's 2 terms here and 2 terms here, first, outside, inside, last. Gotta get all 4 pairs multiplied together. So the first would be 5 times 5. The outside is 5 times square root of 2. The inside is 5 times negative square root of 2, so it's just negative. And the last is negative square root of 2 times positive square root of 2, which is, well, negative square root of 4, which is negative 2. Anytime you take a square root of 2 times square root of 2, it's going to be 2. Now what?
The 5 square root of 2 goes away.
Yeah, those are opposite. They cancel out 0. And I'm left with 25 minus 2, 23.
I was not about to say 27.
Would dream of it. David, did you see Katie playing your Spider-Man?
I'll beat him up.
Okay,
My social justice workers. Is it workers or warriors?
Warrior. Y minus square root of 3 squared. What does y minus square root of 3 squared mean?
Means that the square root just goes away.
No, it means you take the whole thing times itself. The whole thing times the whole thing. Got squared all together. So it's more of a FOIL problem. Yeah, so the first would be y times y squared. The outside would be y times negative square root of 3.
Minus y squared 3.
Yes, minus y squared root of 3. The inside would be the same thing, y times negative square root of 3, so it'll be a repeat there. And then the last, negative square root of 3 times negative square root of 3 is positive 3. Okay, are these going to cancel out on this one?
No.
No, because they're both, it's like minus one of those, minus one of those. So I got y squared minus 2y squared root of 3 plus 3. Number 13, 7 plus 2i, 7 minus 2i. When you foil two things that are almost identical except for the plus and the minus, these are called conjugates. When they're almost identical like that, but one's a plus, one's a minus. The reason they're special is when you multiply conjugates together, the outside inside always cancels out. So you get much simpler answers. 13 is conjugates. Not number 9 was conjugates. Almost everything canceled out. So anyway, we'll do the whole thing now, even though I know the outside and inside will cancel out. So the first is 7 times 7. The outside is 7 times minus 2i. The inside is 7 times positive 2i. And then the last, a lot of us got this one wrong on the semester final. 2i times negative 2i.
Negative 4i.
Negative 4i squared. So the reason we got this wrong was because we just left it as 4i squared. So I squared turns into a negative 1. So really this is minus 4 times negative 1. What's negative 4 times negative 1? Positive 4. So this just turns into a normal plus 4. So as far as the normal numbers go, I see a 49 and a plus 4, which is 53. And then for the imaginary, I see a minus 14i and a plus 14i.
0.
Which is nothing, so they go away. So it's just 53. Two to the 65th times 4 to the 10th. They don't really want you to plug this in the calculator.
They should have said that.
Yeah, they probably should have. They want you to. The calculator wouldn't handle it very well. It would have to write it as a scientific number in scientific notation, because it's too big to fit on the calculator. This is like we're getting into numbers that are like how far is it to the next galaxy kind of thing. Really, really, really big numbers. But they want us to leave it in exponent form. They didn't say that. You can't multiply like x squared times x to the third is what?
X to the 5th.
X to the 5th. But if you have x squared times y to the third, that's not really 5 of anything. This doesn't simplify. So 2 times 4 doesn't really simplify, but I can change 4 into a power of 2. You guys know what I'm saying? 4 is 2 to the what?
2 to the
2 to the
2nd.
second. So I'm going to rewrite this as 2 to the second to the 10th power. Okay, and then 2 to the second to the 10th, how did that work? Multiply is 2 to the 20th. So 2 to the 65th times 2 to the 20th is 2 to the 85th.
Is it 2 or is it 4?
2. Okay, it's not a 4 because the multiplied 2's are all inside of that 85. So you don't actually multiply the 2's together. This means 85 2's multiplied together. It's one of those numbers that doesn't have a name because it's too big and it's too big for us to really understand what it is. How many golf balls could cover, North America kind of thing.
I think at least 3.
Probably about 3. All right.
Math.
Mm-hmm.
Okay. I'm kind of worried about those problems.
Yeah, you and me both.
That's 2 of us. Well, maybe I'll help you with the evens. 14. Okay, yeah, let's go back to 14. Be nice today. $14 is pretty similar to 15. Any ideas what I'm going to do first?
Change 25 into 5 to the second.
Right, I need the same base. 5, this is 5 to the second. So 5 to the second to the third, which would be 5 to the sixth. So 5 to the x times 5 to the sixth is,
5, 6 plus x.
yes, x plus 6. That's as simple as we can make it. I don't know what x plus 6 is, so we just leave it, the exponent as x plus 6. Simplify means get as much stuff together as you can, make it as simple and as small as you can. Okay, let's look at 16, I guess. 16. 27x, 3x plus 1. It's pretty similar again. 27 is probably a power of 3, right? Does anybody know what this is? It's a power of 3? 3 to the third. So it's 3 to the 3 to the x times 3 to the x plus 1. What's 3 to the third to the x?
3 to the third plus.
3 to the 3x. Because now this is multiply, right?
Yeah.
And then when you're multiplying the base, the same base together, what do we do with the exponents? Add. So 3x plus x plus 1 is 4x plus 1. There's some doozies, huh? Or, as Mr. Bale would say,
That's
It's the pits.
just the pits.
Yeah.
We do 17.
I saw him yesterday, but he called me Josh sometime.
He's in the ballpark.
Brown.
Your parents, your parents probably call you Josh too, so you gotta give them some credit. Do they?
My parents don't talk to me. No,
Just be happy they don't call you Shannon. Oh, Shannon, you're a corker.
a what?
A quote from a movie.
I'm not that old.
I always think of it when I hear Shannon. Oh, you're a corker, Shannon.
2.
All right, now what? Probably what kind of problem?
Distributive property.
Oh, that word
Yeah, what's 2 to the 40th times 2 to the 11th? I'm not completely sure what they wanted out of this one. It's 2 to the what?
51st.
51st. Minus, those don't really mix very well. I don't know, I'm not completely sure what they wanted out of that. No, that's all they wrote, I guess. So we'll strike that too. Oh, we probably should talk about 18. I fear these problems, I better help you with them. I'll write it down, I guess. 3 times 4 to the 6 times 7 times 8 to the 7. Alright, any bright ideas?
Multiply 3 to 7.
Yeah, we could put 3 times 7 together, that's true. How about these two guys?
No.
8 into
The same as
2 to the third.
Yeah, these are 4 and 8 are both powers of 2. You guys know what I mean by powers of 2? Like 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So we can turn this into 2 to the second and this into 2 to the third power. So we'll go ahead and do what David said. 3 times 7 is 21 times 2 to the second to the sixth times 2 to the third to the seventh. many 2's do I have? How many 12 and
21.
21 make 33? It's basically 12 plus 21.
What are you doing?
She's slid it under here.
That was the most iconic thing ever.
Oh. Yeah. Bring it over here. She spelled her name wrong. She got the A and the S.
Does Joseph stack stuff in other classrooms, or is that just my classroom?
That's just yours.
Last year.
Joseph is.
Just last year, you're just not to finish that.
Yeah.
It's not worth
You
it.
would make towers over there, like, if anybody touched them, would
Last year.
collapse.
Yeah.
And I'd be like, Joseph! No.
And he would
He
do
thought
it.
it was amusing. Yeah.
Joseph is a weird,
He's a
scary person.
yeah.
And if David's saying that,
Yeah.
But funny sometimes. But also
he makes me mad. Just I don't know why. That is true,
you probably
but
have anger issues.
I don't have anger issues. I'm just gonna no. It's just like I'm gonna call you out for being a retard if you're being a retard. Like that's
There's
just
no
the
anger
thing.
issues at all.
Yeah,
It
exactly.
just so happens that everybody on the planet is a retard.
That is. It just happens to be true. It's not my fault. I'm just saying. Like.
Okay, how do we find the area of a rectangle?
The area
add
is
the-
base
add
times
the-
height.
So this times this, so it's just a fancy way of doing
Don't just
foil.
touch geometry.
Foil problem. On number 20, how do we find the area of a triangle?
No. Base times height divided by 2.
You have to divide by 2 at the end, your answer by 2 at the end. So anyway, it's foil problem. First, 5 times 4. Outside. Inside. And last. What's square root of 3 times negative square root of 3?
Negative. Wait.
Negative.
Negative. Oh, okay.
So, if I do the normal numbers together, 20 minus 3, 17, and then negative 5 square root of 3 plus 4 square root of 3 is negative 1 square root of 3. Now, if this was the next problem, we would have to divide by 2. At this point, next problem's different. I won't do that. You'd have to divide both of these by 2, but next problem is just one term answer. So it's okay.
Oh, that looks angry.
Okay, foil problem. On steroids. How many problems did I say? 24? Okay. Alright, so first, x times x. Outside, x times 4 square root of 6. Can't really do anything with that. The order, we usually put the variable after the whole number and before the square root. So it's just 4x square root of 6. Which means the inside would be 2x square root of 6. And then what is 2 square root of 6 times 4 square root of 6?
8 square root of 6. Wait.
8 square root of 36, which is 6. So 8 times 6 is
48.
38. Your calculators can't do that because it comes out nicely. Everybody's can. Okay, anyway, x squared plus, so these are like terms because they're both x squared to 6's. So we have 6 of those. And then plus 48. Last ones. I'm not gonna copy down.
Sorry.
Well, I was looking at 24 actually. On 24, instead of writing down x plus square root of negative 3, what should you probably write down?
X minus I squared.
X plus I squared root of 3 and x minus I squared root of 3. So go ahead and bring those negatives out as i's, and when you FOIL it. So 23 is 3 plus 2i squared. So that means 3 plus 2i times 3 plus 2i. So the first 3 times 3, outside 3 times 2i, inside 3 times 2i, and last, what's 2i times 2i?
Get a 4.
4i squared. I squared makes it a negative 4. 4i squared, 4 times negative 1. 9 minus 4 is 5, and plus 6i plus 6i is plus 12i. Some very nice calculators can do imaginary numbers. The white ones, mostly. That's not a racial comment, David.
Why?
Everybody was thinking it.
It just so happens to be.
What just happens to be true?
Yeah.
Just like the racial inequalities in America. How come?
Wow, imagine being retarded.
How come when I go to Starbucks they ask me if I want black coffee or free? What's it called?
I don't know. I don't go to Starbucks. I'm not a degenerate.
You can
Well-
get black coffee and black
Not retarded.
Yeah, now you're speaking my language.
How come I'm brown?
You have to ask God that one. I don't know. Actually, I kind of do know. People who live closer to the equator need more sun protection, so they have a darker pigment. Your ancestors.
So built-in sunscreen.
Yeah.
I had a black friend who was like, I never get sunburnt. I don't know why. And I was like, who's going to tell him?
Yeah, built-in sunscreen. Congratulations.
I'm like, it's just...
Probably shouldn't